Hi everyone, welcome to Why Not Engineering again. So today I will show you how to make a digital to analog converter. You will see it's very easy. And why to make this converter? Well, you will see that it's very useful with projects on, for example, the Arduino, because the Arduino has a function called analog write, and this function is supposed to output lower voltage than 5 volt, because you know the Arduino can only output 0 volt and 5 volt. Well, with this analog write, you will see that if you measure the output with a multimeter, you can have a lower output than 5 volt. But yeah, well, in reality, it's not like this. In reality, what the Arduino do is alternating with a square wave signal between 0 volt and 5 volt, and depending on the number that you will write in the analog write function, he will change the duty cycle. So duty cycle is the time when the signal is low on 0 volt compared to the time when the signal is high 5 volt. And so you will see here we're at analog write 155, but if I write, for example, analog write 200, well, you will see, you see what happened. So the high time is longer and the low time is lower. So if you measure it with a multimeter, you will have a higher number. But using a square wave signal like this, it's not really good with a lot of instruments. So what you want is really an analog signal. So what does it mean, an analog signal? It means a continuous signal. You don't want this. You want a continuous signal like the one that you can find on the multimeter. So how can you do this? Well, with a simple RC circuit called a low-pass filter. You can see it here. So it's composed by a simple resistor and a simple capacitor, and this circuit will in fact filter all the higher frequencies. So it will damp all the higher frequencies, and there is something we call the cutting frequency. It will be the frequency above which the signals are damped by more than -3 decibels. So it means if the cutting frequency is about 50 hertz, well, it means above 50 hertz, all the signals will be damped at -3 decibels at least. So I made the circuit here. So I will show you in practice what does it do. So here you have your square wave out of the Arduino that I showed you before. Oh, sorry. And I will put it back at 155 like before. And so now you can see what I have on the output of the digital to analog converter. Here, you see? There is a little bit of ripple, but you can still see we have kind of a constant voltage between 0 volt and 5 volt. So if you look closer, if you look closer, what you can see is that the capacitor is charging when the output of the Arduino is on high, 5 volt, and discharging when the output of the Arduino is on 0 volt. So what can we do to have a lower ripple? Because what we want is, of course, a really constant voltage. Well, you can just change the capacitor value to filter frequencies lower than the actual cutting frequency. So remember, cutting frequency, it's 1 on 2 pi times RC. So if you make RC higher, well, the cutting frequency will become lower, and you will have less frequencies higher than a constant, so higher than no frequency. So now I will change the actual capacitor from 10 microfarads to 150 microfarads, and you will see the result. So here you can see we put 150 microfarads. We have like kind of a perfect line, and so that's exactly what we wanted. We want a perfect line depending on what we write in the analog write function. So here we're at 155 on the analog write function. You will see what happens if I put 200, for example. Well, you see we have a higher average voltage. So perfect, we have an analog voltage depending on the number we put in analog write function. So that's exactly what we wanted. We have a digital to analog converter. So I think it was quite understandable. So I hope you enjoyed the video, and if you want me to explain the low pass filter maybe more mathematically, well, just write it in the comment and I will try to do a video on it. So thank you for watching and see you next time. Bye.